Hello.
Hello.
Hi.
Hi.
How are you?
Nice to meet you.
Nice to meet you.
Nice to meet you too.
I'm Diana.
I'm Beatriz.
I'm Rebeca.
I'm Douglas.
Hi. So I'm Emmanuelle. So I'm very honored that you ask, and I'll be very happy to tell you more about my scientific life and from what I understood why I chose to do this job and why do I like this job and what does that mean to me.
Yeah, before asking the question, could you introduce yourself, please?
My name is Emmanuelle Martini. I'm working in the CEA in France. It's close by Paris. So I've been working here for the last 15 years. So I did my study at the university in Paris. And I did my PhD at the Curie Institute in Paris. And after I graduated, I moved to New York to do a postdoc in the Memorial Sloan Kettering. Actually, I did a first postdoc in the lab of Marianne Osley, and I decided to work on DNA repair and chromatin, like what I did during my PhD. But during my PhD, I was working on human cells. And at that time, in human cells, it was in 1995, and you could not do much. To study the mechanism of the genes, the mechanism of the pathway. It was a bit frustrating to work on mammalian cells. And the yeast was a very good tool to do genetics and more mechanistic approaches. So many of my friends were working on yeast, and I was a bit jealous, and I decided to move on yeast. So I decided to do a little bit the same study, the same kind of study, chromatin and DNA repair, but with a tool that was a bit more powerful at that time. So I've been working on yeast. And that's something that happened often in the US. My boss didn't get a tenure. The tenure is an extension and the possibility to stay in the same institute for another period of time. So she had to find a new location. So together we decided that I will finish my project in another lab in the same institute in New York. So I found another lab to accept that I stay in this lab, and I was finishing my own project. And after staying and finishing my own project, I decided to move on the subject of this lab that were meiotic recombination. And this was also not so far from what I like to do. Because meiotic recombination it's studying DNA repair in the context of the chromosome. So once again, in the context of the chromatin. Okay. So after 5 years in New York, I asked myself, do I want to stay in the States or do I want to come back to France? So I came back to France, first as a postdoc, but in the optic of obtaining a permanent position. So I came back to a lab where I postulated for a permanent position. And I got this permanent position in the CEA. So I can be here for the rest of my life. I moved back to mammalian cells, mammalian and mice, because now we can do much more. With when I did my PhD, the first knockout mice were like a dream. Now it's just like, okay, you need one, you do a CRISPR-Cas9, and you have 10 mice in your facility. So it's a totally different world. Imagine when I started my PhD, I didn't have an email.
Oh my God.
So that was another time. Oh, I'm in a lab and I'm in charge of the subject of the topic of meiotic recombination, and especially I try to understand how homologous recombination works during meiosis compared to how it works during mitotic cycle. So it's a bit specialized during meiosis. So I try to work and study the meiotic specific factors that are going to make the ubiquitous factors working differently. So there are specificities that are in meiosis compared to mitotic cycles. So it's really this part that interests me a lot. And I have a student. I work with 3 students, and we try to get things done.
When did you realize you want to be a researcher?
So, okay, I think I like these things since I was very young, because I've been always very curious.
Mm-hmm.
And I always loved science. I was curious about biology, about evolution, about how can we be here, how can we be what we are, what's the difference between us and the other animals. All these things were very interesting to me, so I hesitated about doing medicine or vet, but for me, this part of thing was a bit frustrating because I could not do research on it. I was just applying things that we know. But, the kind of investigation and research were not in medical school or vet school. So when it was time to decide, I said, okay, I'm just going to do the studies that I need to do research.
Have you ever thought of this as a dream?
In a way that I really want to do it. So I was dreaming about doing it, and I made my dream come true. Yeah, sometimes, as I told you, I thought maybe I'm not good enough, or maybe it's going to be too difficult, or maybe I was, it was like a really little dream that worked.
We would like to tell you that your work about DNA recombination in meiosis is very interesting. And we would like to know what motivates you to work in this project, and what do you think is the most interesting part about it?
When you work on something in science, I think it's not just a question. It's not just something a question you ask to yourself when you were 15. It's also things of the life, the hazardous part of the life that put stuff in front of you during your course. But for sure, the first time of my life I heard about crossover, I was fascinated. I don't know why. And I was 15 or something like that. But at that time, I never knew I will be working on that, ready on that later. But for sure, I've been always seduced by genetics. Genetics was really something that I liked. And the way of thinking with genetics was really what I really appreciate. And I think I'm more into that than physiological studies or even development. It's really the mechanism and the genetics that I prefer. So I always found questions that were more in this kind of thing. Meiotic recombination, as I told you, is really something that combine DNA repair, which is something that I always been interested in, and chromosome organization. So in this field, and the question we ask necessitate to combine results from biochemists, from structure people, from genetics, molecular biology, and that I really like the convergence of all of these fields that are necessary to be able to respond to a question. And I found meiotic recombination a very good deal for that, a very good topic to combine all of this view. And also, a reason why I also try to stay as much as I can in this field is because people are very nice in this field. So maybe we will hear about that later if you keep going in science or in research. There are some fields where people are more sharp or ready. And this one, it feels a bit like a family. So we know each other all over the world. When we go to meeting every year, we're happy to see each other. We exchange the results, more or less. Of course, we don't say everything, but we say a lot, and that's, I think, for me, it's very important. To feel comfortable about exchanging and discussing your results with other scientists, because you cannot know everything on your own. You cannot have all the response on your own. You are lucky to work with a lot of very smart people, so use it and discuss with it.
Recently, we have been studying about the cell cycle. And could you explain how the mechanisms of DNA recombination and crossover are regulated during this meiosis cell cycle?
Okay. Recombination or DNA repair during meiosis, it's a big topic of studies, and it's not so well understood. Okay, so once again, you have the checkpoint, the protein of the checkpoint you heard about, probably ATM, ATR. Yeah, you heard about these guys, check 1, check 2.
Yeah.
The cyclin, the kinase. So we use these guys, but once again, a little bit, sometimes in a different manner, a specialized manner. So we try to understand the two phases, but so far there is a lot to work on to really understand how cells are. Because meiosis at some point it's from an S phase and you stop in right after M phase, except that you do 2 M phase, and it's like you don't really have a G2, or the G2 is a giant prophase 1, and this giant prophase 1 in female, in mammalians, this prophase 1 can stand for their entire life almost. Your cells are staying in prophase 1 for 30 years. Imagine. So, which has nothing to do with cycling cells, you know. And in male, no, they don't stay like that. They keep doing their meiosis very quickly. So it's totally different between male and female. Even if they have to do the same job, once they stay for 30 years, in males, within 2 weeks, you have new spermatocytes. Okay? So there are common points and there are different points. So the regulation of the cell cycle, of this cell cycle, vary between sex. You have in the middle of the prophase, you have specific checkpoint. At the end, you have specific checkpoint, and you have the mitotic-like checkpoint. And the S phase is not exactly the same as the classical S phase, as you have to prepare to enter into meiosis. So you don't have exactly the same cycling. You have specific cycling, because you have to, on the opposite of what's going on in the normal cell cycle, you have to tolerate a lot of breaks, which are totally forbidden in a normal cell cycle. You know, on one hand, in mitotic cycling cells, well, you have a damage, you have to repair, or you have to kill the cells. In meiosis, you have to do, for example, in mice, you have 300 breaks. So imagine, you're programmed to do 300 breaks, and they have to be accepted. These breaks are normal, they are not an accident. So the checkpoints are totally different, because now they're like, okay, we don't have to repair too quickly. We have to repair them in a very specific manner, but we have to check that they are properly repaired, and you can keep going during the phase. We have a checkpoint in the middle of the phase, not just at the end. So it's very, very specific and very complicated, and we don't know all the stuff yet. I think we know more about the cell cycle in mitotic cells and in meiotic cells. So there is still a lot to study on.
Thank you very much for your time and attention.
Okay.
Merci beaucoup.
Good luck, everybody.
So it was a great experience, and we love to know more about the scientist life with you. Really, thank you very much. Merci.
De rien.